IMAC-GHG-LCCP is a software tool that estimates the total direct and indirect CO2 emissions for a mobile air conditioner. Today, I will be walking through how to use the software. Start, select the number of systems that you would like to evaluate simultaneously. Also select the refrigerant that you would like to evaluate for each system. Next, a refrigerant data screen shows different information about the refrigerant selected for each system. The only input on this screen is the amount of leakage, refrigerant leakage per year. The next screen is the parameter selection screen. On this screen, you select the cities that you would like to evaluate each system. In this case, I will select cities from the United States. Nearly 100 United States cities are included in this software. Also on the screen are different inputs about the vehicle being evaluated, the engine pulley ratio and engine efficiency, and the fuel used by the vehicle. Also included is the amount of refrigerant leakage during service. The next screen is the vehicle usage screen, and this shows inputs for each city of the driving distance and vehicle lifetime in those cities. Also included is the percent of vehicles that are manual and percent of vehicles automatic, and the percentage of time the AC is on at each temperature band. The next screen is the component mass screen. The inputs needed for this screen are the mass values for each of the components in the mobile air conditioning system. The total mass of each component is entered, and then each material of each component is broken down by a percentage of that mass. All of these inputs can be loaded in from a template Excel file that has default values for each of these inputs. The software then converts each of these materials into an CO2 equivalent based on the energy needed to manufacture that material. The next screen is the fan power input screen. On this screen, the user enters a fan power and each vehicle speed and ambient temperature. This is used in the calculation of total power consumption of the vehicle. The next screen shows a question about the AC system, whether it is belt-driven or electrically driven. The next screen is the capacity and power input screen. On this screen, cooling capacity and power consumption of the MAX system is entered for a range of ambient temperatures, relative humidities, and compressor RPMs. This load condition is based on SAE standard 2765. Similar to the component mass screen, the data for this screen can be loaded from a template Excel file. final screen is the drive cycle input screen. Here, drive cycles are auto-selected based on the cities selected earlier in the software. In this case, we are only running United States cities, so drive cycles FTP and SCO3 are being used. There's also support for AC17 drive cycle for USA cities. Also, a user-defined drive cycle can be loaded as well. Next step here is to run calculation. The software then takes in all inputs given in the previous screens and calculates the total CO2 over a vehicle lifetime. Calculation typically takes less than 5 minutes to solve. Once the calculation is complete, an Excel results report will be generated. This report gives total CO2 emissions at each city and for each system. Also included in this results report are numerous charts. The next few tabs apply only to USA cities. The first is a weighted tab, which weights the percentage of vehicles in a selection of United States cities. This weighting is then used to come up with a single weighted average grams CO2 per mile for each system. The weighted all tab is only shown when all United States cities are evaluated. In this case, the percentage of vehicles, total vehicles in each city is included in the results template, and a single weighted average for all United States cities is included for each system, and again is charted. That concludes the walkthrough of the IMAC-GHG-LCCP. Thank you.